So we're on page 25. George and Tristan are training to be magicians and are working on a card trick. They have 5 cards of different colors: red, blue, yellow, green, and purple. They are discussing the likelihood of an audience member picking each color, assuming that they can't see the card's color. So let's list the sample space for choosing a card. So we have 5 different colors, right? Red, blue, yellow, green, and purple. So we can just denote them as R, B, Y, G, P. Okay. And what is the probability of selecting each card? So write the probability for each in the table. So we have outcomes R, B, Y, G, and P. We have, so the chance of you rolling or picking this R card is going to be 1 over 5 possible outcomes total. So it's going to be 1 over 5, which we can write that as 0.2. Okay, so just recall that to get a decimal from a fraction, you would just have to divide the numerator by the denominator. So 1 divided by 5 will give you 0.2. Or you can move the decimal place to the right twice to get percentage, 20%. Okay, so you have 20% of you choosing R card from the sample space. And for B is the same thing. We have 1 out of 5 total. For Y, it's also 1 out of 5. G, 1 out of 5. And also for P, 1 out of 5. So when solving a probability problem, it is helpful to construct a probability model. So this table right here you see on number 2 is called a probability model. So it's a list of each possible outcome along with its probability. So possible outcomes and along its probabilities. So probability models are often shown in a table like this. The probability model for choosing a card is shown. We just found them. Okay, so now a probability model will list all of the outcomes which will be greater than 0 but less than 1. Okay, so the sum of all the probabilities for the outcomes will always be 1. So we figured this out in the previous pages. So why is the sum of the probabilities in a probability model always 1? Because the probability model lists every possible outcome that can occur, like this one, right? So we had the probability for R, 1 for B, 1 for Y, 1 for G, and 1 for P as well. So all of them. So the probabilities must add to 1 to account for 100% of the outcomes. Okay. And let's move on to page 26. You can do this later. All right, so let's go over these terms real quick. So a uniform probability model occurs when all the probabilities in a probability model are equally likely to occur. Okay, so each color card in the magician's trick had the same probability of being chosen. So remember we got 1 over 5 for all of them, right? So that means we can say this was equally likely. So that was the example. Okay. When all probabilities in a probability model are not equal to each other, it's called a non-uniform probability model. So an example would be a weather forecast that states there is a 30% chance of rain. That means there is 70% chance of not raining, right? So the sum of these probability is still 1, but the outcomes do not have the same probability. So it's going to be 30 over 100, which is not equal to 70 over 100. So in this case, this would be a non-uniform probability model. This would be uniform probability model because all the probabilities are the same.